Hi! With Raspberry Pi shortage still in place, I've got another alternative for you. Have you heard about Khadas VIM1S? It's a single-board computer very similar to Raspberry Pi. The VIM1S is an upgrade of the original Khadas VIM1. And on the power scale, it's a device rather on the lower end. But that's the whole point of why I chose to review this device. Khadas boards are developed by a China-based company which is making several M-Logic and Rockchip-based single-board computers. You've probably never heard of Rockchip, but they created some of the most powerful ARM-based chips on the market and are cooperating with companies like Intel, Google and Microsoft. And of course, Khadas makes other much more powerful boards than Raspberry Pi 4, but they are also pricier than Raspberry Pi. I needed to know if this low-power, low-price, low-end device could deliver. I'll be honest with you right now. Khadas VIM1S costs only $65. It's available right now and it does splendidly for this price. To summarize it in a few sentences, let me put it this way. It's more powerful than Raspberry Pi 3. It's less powerful than Raspberry Pi 4. It has got GPIO pins to tinker around with. If you want to use it like a low-power, affordable nano server or part of a cluster, you can. Or you can use it like me as one of the headless Docker fleet hosts. Look, it's running great and I can deploy apps I use to it with a few mouse clicks, let's say via Portainer. And last but not least, it's powerful enough to be used as home media center or home theater. And for $65, it's a very good deal.
Okay, so what is this VIM1S? Well, it's a computer, but a tiny one. Look at it. It comes in this small package. And when you open it, we've got the board itself here, a card, a quick start guide, and a separately packed antenna. Its dimensions are only 3.2 by 2.2 inches. You see, its size is almost identical to Raspberry Pi, but these mount holes are not in the same position as are on Raspberry Pi, so if that's of a concern to you, keep that in mind. Now, what can you find on this board? Let's have a look. These two are obviously USB ports. It's rather sad that both are USB 2 ports, there's no USB 3 at all. 100 megabit LAN port, HDMI output, and USB-C power connector. On this side are reset, function and power buttons. And this is a 40-pin GPIO header. Those are the prominent parts. Now the less obvious parts. This is where you attach the Wi-Fi and Bluetooth antenna, if you need that. I didn't. I like the good old cable connection. This is a programmable MCU. MCU stands for Microcontroller Unit, not Marvel Comics universe. And this tiny little thing here is a red and white LED that will be blinking at you constantly for no good reason, driving you crazy and ultimately forcing you to look for a way to disable it without using lethal force. Okay, this neighbor here is 2-channel infrared port, SPI flash chip, I think most of you won't find a use for it, RTC connector and fan header connector. And that's it, I think. Oh, of course not. On the back of the board are a micro SD card slot, 5-volt WIN input, and 30-pin FPC or flexible printed circuit connector. Now that's all there is interface-wise.
If this video brings value to you, please subscribe to my channel and leave a comment down below. Thanks!
Now let's head to the specs, speeds and more. Khadas VIM1S uses SoC or system on chip designated M-Logic S905Y4 quad-core ARM Cortex A35 with speeds up to 2 GHz, with GPU chip ARM Mali G31MP2 with speeds up to 850 MHz. System memory is 2 GB LPDDR4 running at 1176 MHz. These chips give VIM1S the ability to decode and play videos in H.264 and 265 up to 4K at 60 frames per second. regarding the storage capabilities, VIM1S offers you 16 GB of eMMC storage on board, and you can also use a micro SD card slot with an SD card size of your choosing. Okay, moving on towards software. Khadas uses its embedded service called OOWOW to manage the OSs you would want to install on your device. It's pretty straightforward to use. After the device launch, it boots directly to OOWOW, and you can take it from there. OOWOW offers several OS options to you. Today you may pick between Android, Core Elec, and Ubuntu. Ubuntu comes with version options like GNOME GUI and server version without a graphical user interface. I bet you can take it from here on. As I'm focusing on the server version use case of this SBC, I will point you to an alternative approach to bringing this device to life. It is a tool created by Khadas people called the Fenix script. You can find it and download it for free from GitHub. This script allows you to compile and build OS images and customize OS itself and its kernel to your specific need. Using this script, you can create an eMMC or SD card image of Ubuntu or Debian Linux distributions. I've used it to create a headless Debian server image, so I don't need to attach a keyboard, mouse or display to my Vim. See my next video if you're interested in how I accomplish this. It will be all about this headless setup. So let's get back to this OOWOW configuration and installation process. So you can see when you start the device, there's this OOWOW wizard launched, saying Vim can't find any system to boot up. So let's do this. On the upper line, you can see the version of OOWOW itself. The device name is VIM1S and its IP address. You can see I've got it connected to my LAN via Ethernet cable, and you can see this temporary host name on my network. Okay, hit continue. You can see the Ethernet status is connected, so continue. And here we go. You can see 3 versions of Android 11, 1 version of Core Elec, which is a media center type OS. You can use Google to find out more about it. And 2 versions of Ubuntu. 1 version is GNOME with GUI, and 1 is a server version with a different set of packages without GUI. I'll continue with the latest Android 11 from the 21st of October 2022. Let's do this. Okay, download the image. I'll speed this up. The download is finished. Let's install it to eMMC internal storage. I've got no option here because I haven't inserted the SD card into the computer. Install and reboot to the new system. Okay, let's go. The Android OS booted up pretty quickly. Honestly, it beat my expectations about it. This first boot took something around 50 seconds, which is not bad at all things considered. So, what are we going to test first? I know, YouTube 4K video with 60 FPS of course. Let me install YouTube app real quick here and open 4K 60 FPS video. As you can see, even in full screen the video seems fine without significant frame dropping. At 4K and 60 FPS there is about a 1% frame drop, which I am actually okay with, especially with this low-end device. Let me remind you, in the November of 2022 it still costs only $65. Keep in mind that there has been a shortage of chips for a year now in the whole world. The conflict in Ukraine has lasted more than half a year now. Tension around Taiwan between US and China has escalated, and you can't buy Raspberry Pi for like a year now. A quick search in the Google Play Store shows that you can easily install and use Office tools like Word, Excel, of course web browser, everything you need to do the basic work stuff on this device. Let me install Firefox, for example, and open Khadas VIM1S webpage. Oh shoot, this is embarrassing, guys. this page is not optimized for this view at all, just look at it. The web page about this particular device is not optimized to show content decently on this device. It's terrible. Okay, let me try another one. Let's say apple.com. Okay, this looks much better. So we can safely say it's not the problem of this device, it's the embarrassing issue of Khadas web page developers. Shame on you for making this device look bad in public. So that's it for Android. Now let's do the similar for Ubuntu with GNOME UI. Start the OOWOW, hit continue, pick the Ubuntu image, download and install it. Reboot and launch Ubuntu. The default username and password are Khadas. Right off the bat, Ubuntu seems slower than Android on this device. Here's the home desktop. I can find Firefox or Chromium by default. Let's install it and launch it. And open the same 4K 60 FPS YouTube video in it. I would say this is unusable. The frame drop is so significant we can't really watch the video like this. Stat for Nerds clearly states that almost all the frames are dropped, so until someone fixes this, the video playing capabilities for 4K in 60 FPS in the combination of Ubuntu, GNOME, Firefox and YouTube are very, very poor. But it's clearly an issue of software, not the underlying hardware. As you could see before, Android can handle this in much better way. The word processor here, I feel like I could write a decent document on this. So that's the quick overview of Ubuntu on Khadas VIM1S. The last thing to do, let me stress test the CPU and read-write speeds on the SD card on this device. I'll do this on my headless server version OS Debian via the command line. First, let's do the CPU test with Sysbench. VIM1S has got 4 cores, so let's do it like this. Sysbench CPU -- threads equals 4 and run. And you can see the CPU speed, events per second, is around 3500. That's not so bad. Raspberry Pi 3B Plus got me somewhere around 2700. And Raspberry Pi 4 went up to 7000. And the last test will be about read and write speeds to the medium the device is running on. In my case, Khadas VIM1S is running from an SD card. You can do it like this. Sudo hdparm-tt/dev/mmcblk1. The cached and buffered disk reads are 916 MB per second and 65 MB per second respectively. Write speeds are tested with DD. DD, IF, dev0, OF, output IMG, block size is 20 MB, count 5, O flag is direct, and remove the created file. It gave us something around 19 MB per second, which is okay for the SD card. I won't compare this to other devices because there are too many combinations. Some of you could be using like different quality SD cards, eMMC storage on Khadas devices, SSD drives and so on. But at least you know the values for this somewhat default configuration.
So, can this device deliver? I've tried to use it as a Plex Home Media Center running in Docker container on headless Debian, and this tiny device worked like a charm, reading from NAS, decoding H.264 video and streaming it at full HD at 60 FPS. And as you have seen, it can handle more. YouTube 4K video at 60 FPS played just fine with negligible frame drops. I would say Khadas VIM1S delivered. Good job, little guy. That's all for now about this device. If you're interested in how to prepare and run Khadas VIM1S or other Khadas devices as nano servers in headless mode, subscribe to my channel and look for my next video. You will learn about Khadas Fenix script, a little bit about kernel compilation settings, the configuration of network on your device before you even boot it for the first time, and more. See you!